Welcome back. Let's talk about internal divisor of a line segment in a given ratio. So we are going to consider a point P with the coordinates x1 and y1 and another point Q with the coordinates x2, y2. So and we are going to have another point R with the coordinates x, comma what y to be an internal divisor between that line segment. Let's illustrate it. Okay, in the ratio m is to n, let's illustrate it. For example, I have my point P and I have a parallel line like this. So this point P, of course, you know the coordinate is x1, y1, and I have another point Q, coordinate x2, y2. So I have R, that's another point with the coordinate x, comma y. Hope you can see it like this. So now this is an internal divisor. So it divided this line segment PQ into what? It divided it internally. You understand? In the ratio m is to what? N. So here can be m, here can be what? N. You understand? It's not that it divided it equally. If it divided it equally, it will be m is to m or n is to what? N. So I can draw my line here and draw another line here. So, so I have my y and x axis. So where here is P, Q, R, I can say S, T, and what? U. So let me find the coordinate of U. So coordinate of U will be X. That's, it started from here going down. So here will be my X. Now, X, corresponding value of it here will be what? Y1. So I can say that here is my Y. This place, that's value of Y here will be what? Y2. So if you trace it well, trace this one well, if you trace it well. Now, value of my Y here will be Y1. If you trace it well. So, okay, I've gotten this one. So to find the coordinate for this side, it will be the value of here will be x2. As if you bring it down, it will be because the value of x here, touching down the x-axis, it will be what? X2. So then here on this point will be what? Y1. Are you seeing it now? So the corresponding value of y, you know, coordinates x will come first before what? Y. So this is value for x. It traces down to here. Now at this point, what's the value of y? Y1. So finding the coordinate for this one is stay with that x2 and tracing down to this place will be what? Y as the coordinate. So I don't think there's any other thing I'm missing. So here will be what? X1, right? So here will be what? X1. So that this whole place will now be, that's this whole place will now be x minus x1 if you want to get here. So here will be also be what? X2 x2 minus, that's here will be x2 minus what? X. Sorry, minus x. Yes, x2 minus x. Yes, that will be the whole of this place, the whole of this place, x2 minus x. Here will be what? X minus x1. So now, if you look closely in this diagram, you see that we're having two triangles, triangle PRU and triangle RQS. So if you look where again, the two triangles, see it, right angle, right angle. Know that every triangle is the same. You sum up to 180 degrees, whether scaling, isosceles, equilateral, or what, they are all equal. So therefore, we can probably say that triangle PRU is similar to RQ what? S. Therefore, their ratio of corresponding sides must be what? Equal. So P, that's PR all over RQ. RQ. they must be equal if we say that they are similar. So again, PO, that's the horizontal side of this one, then horizontal side of this one, ROS must be also what? Equal. Then the vertical side of this one, RU, all over vertical side of this one, QoS must be also be what? Equal. Now our PR is what? M, all over RQ is what? N. So they are what? Equal. So now to find the value of my x, let me use the horizontal one. You know that horizontal is x-axis. So I'm going to have PU all over ROS, which will yield what? My PU is what? PU. So it will be x, that's this x minus corresponding value of x here, which is minus x1. As you can see, it's already here. Now, my ROS will be x2 minus corresponding value of x here. So as you can see, x minus what? That's x2 minus what? X is already here. So this x2 minus corresponding value of x here will give me this. Is equals to m over n. So x minus x1 all over x2 minus x is equals to m over n. So we can do what? Cross multiply. When we cross multiply, we are going to have n into x minus x1 is equals to m parentheses x2 minus x. So when we multiply, nx minus this times this nx1 is equals to mx2 this times this minus mx. So we are going to collect like terms. We are going to say that mx2 then plus, that's this one coming over to be plus nx1 is equals to, now this nx staying here, this one coming up will be plus mx. So we are going to have mx plus nx is equals to mx2 plus nx1. You understand? Nothing changed. Plus is commutative. What is common? X. This divided by this, you get m plus n is equals to mx2 plus nx1. We divide by m over n, m over n. So our x is equals to mx2 plus nx1 all over m plus what? N. So that's our value for x. So we have found the internal divisor for x, you understand, for x axis or for x. So we are looking for y now. So let me clean this side so that we can find our y. So let's continue. So we are now looking for y, that's the coordinates for, we have coordinates x and y. So we are looking for y value now. So for y, we use the vertical one. You know that y is always what? Vertical. So RU all over QS. So now corresponding value of RU here will be RU, which is y, that's y, minus corresponding value of y at u will be what? Y1. So we have minus what? Y1. I seen it now. So here, this place is supposed to be y minus y1. You understand? This RU. So to get this place, it will be this y minus what? Y1. So all over QS. QS will be what? Y2. That's this value, Y2. S will be what? Y. Y2 minus Y. So here will be Y2 minus Y. So it's equals to M over N. So it's going to be Y minus Y1 is equals to M over N. So we can cross multiply. So we are going to have M into Y2 minus Y1 is equals to N into Y minus Y1. This time this will give us my 2. This time this will give us minus my. This time this will give us y. This time this will give us minus y1. Wow. So let's collect like 10. So we have my 2. This one coming here, y1 is equals to my plus 1. Do you understand what I did? This one is here. This one coming here is this. This one, I this more. It's not that it's confusing, but look at it here. This one coming here to be ny plus my. So I just used my before what this. So you know addition is commutative. So I have my plus 9 is equals to this plus this. I did not change anything. What is common here? Y. Remember, we are looking for y. So when we divide, so we divide by m plus n. So my y is equals to my2 plus ny1 all over m plus what n. So I can now say that those my values, that's the internal divisor, the value of x and y will be the value of x and y will be, let me clean this since we have known this one is for y. So it's going to be, you know that x comes first before y. So it's going to be, um, let me write it here. So it's going to be r with the coordinate, that's our internal divisor, is equals to mx2 plus nx1 all over m plus n, comma my2 plus ny1 all over m plus n. So these are the coordinates, the two coordinates for x and what y. Thank you for watching and may God bless you. Bye bye. I forgot to tell you something. So in a special case whereby this internal divisor divides this line segment PQ in like at the center, that's at the center. Therefore, the midpoint, this r s comma y becomes the midpoint of the line PQ when it divides it at the center. Well, that means that m will now be equals to what? N. So it will be n ratio n. That's 1 is to what? 1. So the formula is giving us, that's midpoint. The midpoint, the formula is giving us for x is equals to x1 plus x2 over 2. Now for y, it is giving us y2 plus y1 all over 2. So these are the formulas. These are the formula. When it divides this at the center, understand? So it becomes the midpoint. So that's the formula for midpoint. So bye bye.